Hi everyone. So today we're going to do the lesson on translations with vectors to continue our discussion on translations. Now you're actually going to have to skip over a page in your notes packets to get here. We are going to skip 4-5 for now. We'll cover that when I'm back next week. 4-5 was just a little bit complicated and I didn't want to have to try to teach that through a video, but this one should be okay. So we're going to hit 4-6 today and then we'll come back to 4-5 tomorrow. So just make sure you're on this page in your notes packets. So still talking about translations, but now we're doing translations instead of reflecting over parallel lines. We are going to be doing them with vectors, which is a fancy name for an arrow. Okay. The mathematical definition of vector is a quantity, all right, because we can give a numerical value to them that can be characterized by direction and magnitude. Which, if you remember, direction is, what direction you're moving in, and magnitude is how far. Magnitude is your distance, okay? And so we use these vectors in the coordinate plane, and we treat them like coordinates in the coordinate plane. So a vector technically has what's called a horizontal component and a vertical component, and I'll give you just a second to make sure you have those things written down. But if you think about on an XY plane, okay, the x-axis is what controls your horizontal movement and the y-axis is what controls your vertical movement. So that's where these come from. So for example, okay, vectors can be written as ordered pairs. And here's what this really means. So my vector is actually the arrow. All right, so you'll see like an arrow here. And to determine or to describe where that vector's at, what I say is, here's how far left and right it went. And so the horizontal distance here is A. And here's how far up and down it went is B. And then I write those as a coordinate, just like I would write any coordinate in the coordinate plane. I would say X comma Y or A comma B. Okay, and then I would name this vector AB. Okay, and you're going to see what that means when we start doing some of these practice problems. So example 1 down here, and we're going to get to another example like this later, so I'm going to go kind of quickly through this one. Don't stress if you don't catch it. You're going to see it again in a little bit. It says translate ABCD, which is this rhombus over here, by this vector, okay? And this just estimate visually stuff, I want to be a little more specific, so actually I'm going to get rid of that. We're gonna be more specific. So I want to translate in this direction. I want to take this entire shape and move it in this direction, and the length that I need to move it is the exact length from Y to Z. So I'm going to bust out a ruler. I'm going to measure. It looks like that's about 2 centimeters. By the way, I always do my measuring in centimeters just because it's easier. Okay, you don't have to worry about your fractions. You can just go 0.1, 0.2. You really want to use inches, knock yourself out. Okay. And what I'm going to do is I'm going to go to each one of these corner points and I'm going to move in that same direction. So see how I'm keeping the ruler in general the same direction as the vector. I want to keep my ruler so that it's parallel to my vector, and I might not be exactly right, but I'm pretty close. And then I want to go that same distance, which I said was 2 centimeters. So B is going to move over here and become B prime. Then I'm going to go over here to A. And again, keeping it straight horizontal, just like it is up here. My A is going to move 2 centimeters over, so it's going to go right here. And I'm going to name that A prime. My C is going to move 2 centimeters over. And that would be C prime right here. And my D is going to move 2 centimeters over. And then I can just reconnect my dots. And I've successfully, almost, translated my rhombus from here to here. So that's a translation by this vector. Okay, you're also going to see problems like this where you're working with vectors in coordinates, okay? And so to translate a point in the coordinate plane where I give you like an XY coordinate, you're going to add the vector coordinates to the pre-image coordinates. And you're going to see what that means in just a minute, but go ahead and write that down. Okay, so a line segment has endpoints a 5, -2, and b 3, 7. What this vector is really saying is that I'm going to take these coordinates, I'm going to take the whole segment and move it to the left 1, because on the x-axis a negative would move to the left. And then I'm going to move to the up, I'm going to move up 4. So this is left 1 and up 4. Because this is telling me left and right, this is telling me up and down, okay? And I want to figure out where are my new endpoints going to be. Well, I could draw the graph and physically do this translation, okay? Or I can just use some addition, and I'll show you what I mean by that. So the big thing I want you to mark down, and actually I'm going to highlight this, is that to do these, you always want to do pre-image, so that's your original, plus the vector, and that gives you your image. Okay, and that's kind of the strategy you're using every single time. So pre-image plus vector equals your new image. And the questions are going to be worded a lot of different ways. Sometimes they're going to give you the pre-image and the vector, and you have to figure this out. Sometimes they're going to give you this, and you have to figure out the vector. Sometimes they're going to give you this, and you have to figure out the pre-image. So that's why having this as sort of like a formula is good. Okay, so my first coordinate is 5, -2. And I'm going to write these this way just so you can see what I'm doing with these. So there's my original pre-image. I'm going to add to these my vector, which was -1, 4. So I'm adding my x to my x and my y to my y. Okay? And I want to know what that will equal. Well, 5 plus -1 is 4, and -2 plus 4 is 2. So my new coordinate there is going to be 4, 2. Okay? I really just did 5 plus -1 and -2 plus 4. And then I'm going to do the same thing, and this one I probably won't stretch out as much, but I'm going to take 3, 7 and add it to -1, 4. 3 plus -1 is 2. 7 plus 4 is 11. And so my new vector, or my new image would be 2, 11. And so if I drew a segment between these 2 points, and then I drew a segment between these 2 points, I would find that the segment would be exactly the same. It would just be slid over to the left 1 and moved up 4. Okay? So these right here would be my final answers. Good? Hopefully? All right. So, example 3 and 4. And again, this is going to be where it's important for you to remember pre-image plus vector equals image. And I'm going to try to write this a little differently. Okay, hopefully it still makes sense to you. I've got something here. Okay. So, the point 2, 6 is translated to the point -4, 10. So 2, 6, that's my pre-image. That's where I'm starting. And it's translated so that it ends up here. So that means this is my image. And I want to find the vector. Okay? So I know that 2, 6 plus some mystery vector is going to give me -4, 10. Okay, that's kind of the setup that I'm looking for here. Well, if I break that down, that means that 2 plus x must equal -4. Okay? And if I take 2 away on each side, I get that x is equal to -6. Okay? Gosh, I might need some more space for this. I'm going to move down here. So that was how I found my x. I said 2 plus x equals -4. Now I'm going to find my y. 6 plus y equals 10. 6 plus y equals 10. Take the 6 away. Y equals 4. So here's my x, here's my y, And that means my vector, which is my final answer, would be -6, 4. Okay. So if I applied this vector to this coordinate, my end result would be -4, 10. Sorry, that got a little messier than I expected it to be. Okay, the image point 0, 3 was translated by the vector to -5. Find the original pre-image. So here's my image, here's my vector. So this time I have that, I don't know what my pre-image is. So notice that's where I'm putting my x and y, plus my vector, which was 2, -5. Okay, and it's going to end up at 0, 3. Maybe I'll try to do this one without writing it out, because sometimes I think writing it out actually looks more confusing. So I know that x plus 2 has to equal 0. Okay, because when I add x to 2, it's going to give me 0. So I have to think about what x would be. What plus 2 equals 0? Well, that would be -2. Okay, because -2 plus 2 equals 0. Then to find y, I know y plus -5 equals 3, which is really like saying y minus 5 equals 3. If you needed to write that out, y plus -5 or y minus 5 equals 3, you could. Okay, and then I would add 5 and add 5, and you get that y equals 8. But some of you may not even have to. So 8 plus -5 equals 3. So my pre-image, which is what I was solving for, is this right here. Okay, so as long as you know this setup, you should be able to plug information in and solve for whatever it is you're missing. Okay, one last example to talk about here. Well, kind of two examples. Oh, and this should say n underneath it to show that that's vector n. Oops. So draw the image of the figure under a translation of the vector. So this is telling me to translate by vector n, and this is vector n. Okay, so I'm going to use my ruler again, and I'm going to measure vector n, which this time I made it like 2.5 centimeters. Okay, and then what I want to do, by the way, why don't you just follow along? Why don't you just watch me do this one time, okay? And then when I'm done, try it on your own, okay? So that you can make sure you're seeing everything that I'm doing. So I kept, and keeping it parallel now to that vector. And this is kind of tough. I mean, I guess we could get really picky, but really overall, you want to make sure that this line here is parallel to this, okay? And you kind of just have to visualize, all right? So I think that's pretty close to being pointing in the same direction as this. I'm going to line it up so it's right on the end there. Again, I'm looking for where it's parallel. That's probably good. Okay, so again, I'm looking for this line here to be parallel to that line. How's that looking? Pretty good. Okay, and I'm going 2.5 centimeters, so that would go right here. Okay, and then I'm going to do the same thing with this one, and I'm going to keep that line parallel again. So I want this line and this line and this line, all of those lines to be parallel to each other, and 2.5 centimeters. Okay, and then same thing from this end point, trying to keep that line nice and straight. I'm going to go 2.5 centimeters, draw a dot. And then I'm going to reconnect my points. Okay. And I've now taken that triangle and translated it by that vector. Now this next one's a little strange, but I put it in here because there are some in your homework like that. You'll see in this one, I don't have a separate vector drawn anywhere. It just says ray CD. Do you see how CD is part of the picture? That means I'm going to take CD and turn it into a ray. The thing you have to be careful of is this is starting at C and going towards D. It does matter. You can't mix them around. So starting from C going to D means this is my arrow right here. Okay? That's what I'm going to measure, and that's how I'm going to move. So I'm going to measure that, and I'm going to find that this is about 1.5-ish centimeters. Probably close enough. 1.5. Okay? And what that really means is point C is just going to move to here. This is really going to be now C prime, right? And point D is going to start where it's at. Again, I'm trying to keep this so that this is all in one straight line. I'm going to go 1.5 centimeters down here, and this is now going to be my D prime. But now I have to move all the other points too along that same path. So trying to keep it parallel, I think that's pretty close. 1.5 centimeters. That's now going to be E prime. Okay. This one, trying to keep it parallel, pretty good. 1.5 centimeters, that's now going to be A prime. And one more, B is going to move probably right there. 1.5 centimeters, and that's B prime. Connect all my points back together. It should look roughly the same. I mean, I do understand like this right here, this should be straighter, but there is going to be some measurement error, especially since you're just kind of estimating that parallel piece, okay? But that looks pretty good, okay? We translated it this far, all right, in that direction. So that's how these translations work. Okay, so homework for tonight, you're going to want to look in your homework packet, and you are looking for Lesson Master 4.6b. Okay, make sure you're not looking at 4.5 or anything like that. You are looking for 4.6b. That's the stuff on this translations. We're going to skip over 4.5. We'll come back to it tomorrow. Okay, or I'm sorry, Monday. Okay, so I hope you guys have a great weekend. Please try to get this done before you leave class today. Rulers are up on the front table.